Standard 8, Chapter 9, Friction. You might have seen a driver of a car or a truck slowing down the vehicle at a traffic signal. You too slow down your bicycle whenever needed by applying brakes. Have you ever thought why a vehicle slows down when brakes are applied? Why is it difficult to walk on a smooth and wet floor? You can see in the figure. A boy falls down when he steps on a banana peel. Force of friction. So let us see what is force of friction. You saw that if you apply the force along the left, acts along the right. So it is opposite. If you apply the force along the right, the friction acts along the left direction. In both cases, force opposes the motion of the book. The force of friction always opposes the applied force. Please underline which are the factors which are affecting friction. You can see the activity, figure 9.4. In which case is the distance covered the minimum? What is the distance covered by the pencil cell different every time? Try to reason why. Friction is caused by two irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them. When we attempt to move any surface, we have to apply a force to overcome interlocking. On rough surface, there is larger number of irregularities. So force of friction is, mark this, greater if a rough surface is involved. We see that the friction is caused by the interlocking of irregularities in two surfaces. It is obvious that force of friction will increase if two surfaces are pressed harder. You can experience it by dragging a mat when nobody is sitting on it and when a person is sitting on it. Recall your experience when last time you moved a heavy box from one place to another, figure 9.6. If you have no such experience, get that experience now. What is easier, to move the box from rest or to move it when it is already in motion? The force required to overcome friction at instant an object starts moving from rest is a measure of static friction. On the other hand, the force required to keep the object moving with the same speed is a measure of sliding friction. When the box starts sliding, the contact point on its surface do not get enough time to lock into the contact point of the floor. Mark this. So the sliding friction is slightly smaller than the static friction and you find it somewhat easier to move the box already in motion than it gets started. Friction a necessary evil. Recall also how difficult is it to move on a wet muddy track or a wet marble floor. Can you imagine being able to walk? Would it be possible if there is no friction? You could not write with pen or pencil if there were no friction. When your teacher is writing with chalk on the blackboard, its rough surface rubs of chalk particles which stick to the blackboard. If an object started moving, it would never stop if there is no friction. Mark this. Figure 9.8 says, on the other hand, friction is an evil too. It wears out the materials, whether they are screws, ball bearings, or soles of shoes. Friction can also produce heat. Vigorously rub your palms together for a few minutes. How do you feel? When you strike a matchstick against the rough surface, it catches fire. You might have observed that the jar of mixture becomes hot when it runs for a few times. These are the few examples you can see. Figure 9.10, figure 9.9. Now we go to increasing and reducing friction. Have you ever thought why sole of your shoe is grooved. See the figure? It is done to provide shoes better grip on the floor so that you can move safely. When you are riding a bicycle, the brake pads do not touch the wheels, but when you press the brake level, these pads arrest the motion of the rim due to friction. The wheel stops moving. You might have seen that kabaddi player rub their hands with soil for a better grip of their opponents. Powder is sprinkled on the carom board to reduce friction. The substance which reduce friction are called lubricants. In some machines, it may not be advisable to use oil as lubricant. An air cushion between the moving part is used to reduce friction. See figure 9.13. Wheels reduce friction. When one body rolls over the surface of another, the resistance to its motion is called rolling friction. Rolling reduces friction. It is always easier to roll than to slide a body over another. That is the reason it is convenient to pull luggage fitted with rollers. Since the rolling friction is smaller than the sliding friction, sliding is replaced in most machines by rolling by the use of ball bearings. Next, we have fluid friction. You know that air is very light and thin, yet it exerts frictional force on objects moving through it. Similarly, water and other liquid exert force of friction when objects move through them. In science, the common name of gases and liquids are fluids. So we can say fluids exert force of friction on objects in motion. The frictional force exerted by fluids is also called drag. So it depends on its speed with respect to the fluid. The frictional force also depends on the shape of the object and the nature of the fluid. Birds and fishes have to move about in fluids all the time. Their bodies must have evolved to shapes which would make them lose less energy in overcoming friction. Look at the following figure 9.17. Friction opposes the relative motion between two surfaces in contact. It acts on both the surfaces. Friction depends on the nature of surface in contact. For a given pair of surfaces, friction depends upon the state of smoothness of those surfaces. Friction depends on how hard two surfaces press together. Static friction comes into play when we try to move an object at rest. Sliding friction comes into play when an object is sliding over another. Sliding friction is smaller than static friction. Friction is important for many of our activities. It can be increased by making a surface rough. The sole of shoes and the tires of the vehicle are treated to increase friction. Friction is sometimes undesirable. Friction can be reduced by using lubricants. When one body rolls over another body, rolling friction comes into play. Rolling friction is smaller than sliding friction. In many machines, friction is reduced by using ball bearing. Fluid friction can be minimized by giving suitable shapes to bodies moving in fluids. Okay, so read the lesson again.